Factors. Factors are any pair of whole number. We say that factor of 8, for example, will give us two things you can multiply to give you 8. They are the factors. That is 1 times 8 is the factors. 2 times 4 factors. What again? Nothing again. This means that the factors of 8 are 1, 2, 4, and 8. Is that clear? So factors are any pair of whole numbers that give you the value of the fact of the whole number you are looking for each factor. Prime numbers, very important. Prime numbers. What are prime numbers? If a whole number has 1 and itself as the only factors, that number is called a prime number. For example, if a whole number has 1 and itself as the only factors of that whole number, the whole number is a prime number. For example, prime numbers are 2, because 1 times 2 is 2. So 1 and 2 are the only factors of 2. So 2 is a prime number. 3 is a prime number. 5 is a prime number. 7 is a prime number. 11 is a prime number. And so on. So the first 5 prime numbers are 2, 3, 5, 7, and 11. So prime numbers are the number that has 1 and itself are the only available factors. 1 is not a prime number, take note. Odd numbers. Odd numbers are those numbers that no number can divide without a remainder except 1 and itself. And 1 is also an odd number. For example, 1 is an odd number, 3 is an odd number, 5 an odd number, 7 an odd number, 9 because 9 is an odd number, 2 can't divide it, 11, 13, and so on. So odd numbers are the numbers that 2 can divide and have remainder, including 1. 2 can divide and have remainder, including 1. That is 3, 2, 5, 7, 9, 11, 13, 1. These are odd numbers. Take note. Even numbers. These are even numbers. The numbers that 2 can divide without remainder. 2 can divide them completely. That is, 2 can divide 2, 4, 6, 8, 10, and so on. These are the even numbers, the prime numbers, and the odd numbers. Take note. Let's look at fractions. A fraction has the numerator and denominator. That is to say, if A and B are integers, then A over B is a fraction. This implies that 2 over 3 is a fraction, and so on. 1 over 2 is a fraction, and so on. So it must have numerator and denominator. Now let us look at how we can combine fractions. Multiplication of fractions. When multiplying two fractions, for example, 2 over 3 multiplied by 1 over 2, you will simply multiply the numerators and multiply the denominators independently. That means that, say, 2 times 1, 2, and 3 times 2, 6. That is how to multiply fractions. Then, division of fractions. While dividing fractions, for example, A over B is a fraction, divided by C over D, another fraction. What you do is, to divide a fraction, you are going to interchange the numerator and the denominator of the divisor, then multiply. That's so that you write multiplication, then change, let the denominator of the divisor come up and the numerator of the divisor come down. You have D over C. To say A times D, AD, B times C, BC. That is how to handle division of fractions. Now, let us do a practical example. Let 2 over 3 and divide by, let's say, 4 over 7. To solve this, you say 2 over 3. 4 over 7 is the divisor. You are going to interchange the numerator and the denominator by saying 7 over 4. Then multiply as usual. 2 by 7 will give us 14. 3 by 4 will give us 12. This is supposed to be your answer, but because 2 can divide 12 to give us 6 and 2 to give us 7, you can have it as 7 over 6. Then to give us one whole number, 1 over 6 as your final answer, because 7 is bigger than 6. So it's an improper fraction. You are going to leave it in mixed fraction as your answer. Let's look at significant figures and decimal numbers. Decimal places. 234.312, for example, to 2 decimal point, will just mean you will move from this point 1, 2. Your answer becomes 234.31. This is your answer in 2 decimal places. So you start moving from the point then to the right hand side. If you have 0.0348 to 3 decimal places, to solve this, start from 0 again. You move 1, 2, 3. You have 0.03. Now 4, but 8 is bigger than 5, so you approximate 8, and I have 5 as your answer. This is your answer in 3 decimal places. I hope it's clear. Let's go to significant figure. In significant figures, we don't count the 0. If 0 is the statement of question given to you, you don't count 0 while counting that figure. You are going to start from the first value, but not 0. To say, convert 123.7812 to 4 significant figure. This means that the first value is 1. You move 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3.7. But the 8 is above 5. You move 1 and have 8 as your answer. But if you have 0.025 to 2 significant figure, your answer becomes, you won't start from here because it's 0. You start from the first value, first positive value. That is from 2. 1, 2. So 0.025 is 2 significant figure. So as well, if you have 0.1256 to 1 significant figure, you will start from here because it's 0, 0, 0. So you start from the first alphabet, from 1. So you move 1. So answer becomes 0.001. 1 is the first movement. So 0.001 is your answer to the 1 significant figure. But if you have 2, 5, 6, 7 to 3 significant figure, to solve this is 1, 2, 3. That is 2, 5, 6. And 7 is big enough above 5, so you're going to move 1. You now have 7, 0. Let's see that. But if 7 is less than 5, so you are going to make a 0. That's if you have 2, 5, 6, 4, for example, and you want to move it to 3 significant figure, you move 1, 2, 3. So 2, 5, 6. Everything remaining becomes 0. Becomes your 3 significant figure. But in this case, 1, 2, 3. Here is 7. You move 1 to here, becomes 7. Every other thing becomes 0. This is your 3 significant figure for this particular question. I hope it's clear.